Howdy folks, we're going to keep moving on here now, looking more at these objects and vectors or lists. Technically we're going to be vectors. The distinction's not all that important yet. We'll get there more later. But if you take a look at the book, the idea here is they can give you, say, the values on the sides of a die. So we can say something like die is 1:6. And then when we run that, we're going to get this list of values here, the vector of values here. So from 1 to 6, we get all the different values out here. Now, what they didn't show you necessarily, and this is good practice here, is you can get out individual values. So if I want the third value in the list, and unlike most programming languages, the first value is index 1. So this is like the index that it's at here, the third value. So the first one is 1, the second one's 2, the third one's 3, right? So if I say, hey, I want die 3, we're going to get the value 3 out here. Right? If I just say I want all the values of die, right, we're going to get all the values back out. Right? So this is die of sub 1, sub 2, sub 3, sub 4, sub 5, sub 6. So we start at 1. It's not index 0, which is super weird, but that's okay. So that's the basic book example here. So we don't need to do too much of that here. So this gets the third value. Right? Gets all the values. Okay, and this is is the range from 1 to 6. As separate values. Okay, just adding a couple notes here. I've gotten into a bad habit to not use comments. We tend to frown on them in the industry, and our little rainbows and unicorn land that says our code should be so easy to read because our variable names are great, you should never need comments. And it's a bit of a pipe dream, but we'll work with it. So usually I tell folks to holler at me, but I'm doing videos here and there's no one to holler at me, so I'll do my best to try and come back and add comments there if I forget them. So if I wanted to do a more interesting value here, so like if I had, I don't know, instead of saying, hey, my kids don't eat bread all 7 days of the week here, or not all the kids want to have sandwiches all the time. So maybe I want to have a set of values here for how many kids are having a sandwich on a given day here. So this is, I don't know, sandwiches on days or something like that here. And then we're going to assign it. Now to make a vector, you get this cool little C shortcut here. I don't know who came up with it. We say C. And then I can say for particular values here. So maybe now days of the week should start on Monday, because if we call the weekend of Saturday, Sunday, this week shouldn't start on Sunday because that's not the week end, that's the week beginning. I'm always confused by that. So I'm going to pretend Monday's the first day of the week here. So we'll say on Monday we do 6 sandwiches for the kids. And then on Tuesday, maybe only 5 of them have sandwiches because one of them does something else for lunch. And then maybe we'll go back to 6 sandwiches on Wednesday. And then on Thursday, I'm gone teaching all day, so I'm sure they're going to do sandwiches for lunch. And then on Friday, usually we try and do something fun, so probably no sandwiches on Friday. And then on Saturday, maybe we'll pack some lunch to go out and do, I don't know, go somewhere fun, so we'll do 6 more sandwiches. And on Sunday, we'll do some sort of hot lunch. So not the most interesting list here. This is sandwiches on days. So now I'll have this list of values here. If I run this, we can see, now it's slightly different here. We had int here, now it's num for numeric. Don't worry too much about it here. We're saying there's 7 different values, right? So from value index 1 to value index 7, we can get those out here. So if I wanted to get how many sandwiches it is for the week, right? So we'd say sandwiches for the week is going to be, now there's some built-in cool things. We can say, hey, I want the sum of my sandwiches on days, right? And we can see how many sandwiches we need for the week. Sandwiches for the week is 29, right? That's the sum of 6 plus 5 plus 6 plus 6 plus 6. Pretty straightforward here, which is nice. So it's a nice little built-in way here to do this. Now I've got this sandwiches for the week. Now that is multiplied by 2 times, right? So this is slices of bread needed per day. I could say we'll say is 2 times my sandwiches on days, right? So the slices of bread needed per day. We're going to assign the value of 2 times this. Now 2 times a vector here, or a list here, is a little bit weird, but what it's going to do is multiply each of those values by 2, right? Because it's slices of bread now. So if I needed 6 sandwiches, I need 12 slices of bread. If it was 5, and on and on and on, right? So it should just be double the other one. This is the sandwich math is pretty easy here, which is nice. So then I might need the sum of, I don't know, total, I can't spell sandwiches. There's a H in there, so that's not right here at all. But now the total slices of bread, right? Total slices of bread for the week is going to be, I keep wanting to say equals here, but this arrow notation is gonna get to me here. And we'll say the sum of my slices of bread per day. Okay? And this is now how many slices of bread I need, and then this will be loaves of bread of bread. And maybe we even have like slices per loaf, maybe? That might be a nice variable name to have here. Slices per loaf is going to be, we'll say it's 18, right? Because we have to throw away the butts because for some reason the kids won't eat that. And then we have my number of loaves or loaves needed for the week is going to be the total slices of bread, right, divided by my slices per loaf. Now let's see if these ones run for us here. So we should get my, oh my goodness, it's alphabetical here. Loaves needed for the week is 3.22. Now, if you go to the grocery store and you tell them you want 0.22 loaves of bread, they're going to look at you like you're crazy, right? We don't do that. So what we need to do is we need to round this. And really, we're going to round up here. So I think if I just say round here, this is not going to do what we want, right? So let's give that a run. And then we get 3. 3 is not going to be enough, right? So we want to round up. So I don't even really remember how to do that right now. So R round up here. We'll just go Google real quick. R round up here. There we go. So we get not round, we want ceiling. So this is, we'll round up here for us to the ceiling. The other option there should probably be floor to round down. Let's give that a rerun here. And then we get, that's a 4. Fantastic. So I can order 4 loaves of bread when I go to the store here. And if I wanted to know how much money I was spending, right? So this is, I don't know, cost for bread is going to be, we probably should say, cost per loaf, right? Per loaf, we'll say that's, I don't know, I think it's $1.99 per loaf here for that cheap white bread stuff. The Meyer brand, whatever it is here. I could go look it up, but it's just an exercise here. So then, I don't know, cost of bread per week is going to equal my cost per loaf times the loaves needed for the week. Loaves needed for the week. Here, and we'll see what we get. Let's see how much we're spending on bread every week here. So my cost bread for the week, $7.96. Not too bad, but that's just the bread, right? Then we got to add the peanut butter and jelly, the meat and cheese, and all sorts of this stuff. But the idea here is I've got nice names for everything. Right? We didn't really need to give any of these names. And like we could have just put some numbers here. But having variable names here lets me come back to this and see what's happening. And then if I want to go change these things, I can go change them pretty easily here without having to know, hey, that $1.99 is the cost per load. Oh my goodness, loaf. I can't type here. Let me change that. I might get a little confused there otherwise. All right, so now we've got our cost per loaf. That's a little better. So having variable names let me come back to it and change it and see, I can go and edit this and change it as the price of bread goes up and down or whatever happens to be. All right, so this is working with these vectors here. Again, you can do the same thing with the list notation, right? Just say, hey, I want from 1 to 6, which is great. If I know what the values are, we can just assign them right here. And then, if you want to, you can even multiply vectors by vectors. That gets to be a little funny here, and the book has a good example because it's not, if they're not the same size, it's okay. It's just going to keep repeating the smaller vector if it's evenly divisible by the size of the larger one. So I can't multiply a size 6 and a size 7. It'll get confused here. So if I say my sandwiches on days times my die, it's going to get confused pretty quick here, right? The length, longer object length is not a multiple of shorter object length. Well, that's a fun way to say it. Not divisible, not evenly divisible. Right, but I could multiply it by, that's 7, that's probably no good. So let's take the die, right, times, we'll just do a list of, do 1 to 3 here. So die times 1 to 3 means I'm going to multiply by 1, 2, 3, and then 1, 2, 3. So the first one multiply by 1, the next one by 2, the next one by 3, and then again by 1, by 2, and by 3. So it's just going to keep refilling, right, repeating that smaller vector here. So it repeats the smaller vector and multiplies values at the same index, right? So this idea of this index here, so index 1 gets multiplied by index 1 of the other, index 2 by index 2 of the other, 3 by 3 of the other, and that's what we're going to get for this. Repeat. I love that it's spell checking in my comments for me here, which is so cool. All right, so that's some quick work on some of these. Again, take a look at the book example. I'm trying to give you some different things so you can see it more than once.